Alright, I'm going to talk you through how to do a practice problem we've done in class, and here goes. I gave you information for standing waves, and we know that we're going to set them up like the harmonic number. Here's going to be the drawing, frequency, wavelength, and wave speed. And I think what we're trying to illustrate to you is that the wave speed is going to continue to stay constant. It's going to equal frequency times wavelength, and we'll continue coming back to this. Here I have the fifth harmonic. So we're going to look at the fifth harmonic. This is the first one we'll start with. And I think it's important for you to make the drawings. And the drawings are going to look like this. I put dots down, and I'm just going to connect them. Those are going to be my nodes and my antinodes. And I tell you that the wavelength is 5 meters. And if you see here that this is 5 meters, right? 1, 2. You are going to see that you can actually calculate the size of any one of these is going to be 2.5 meters. And by knowing this one's 2.5, this one's 2.5, 2.5, 2.5, 2.5. I get information about the boundaries. The boundaries are going to be 12.5 meters from side to side. So I know that this is going to be the wavelength of my second harmonic. So I know something is going to be 12.5 meters from boundary to boundary. Now, there's something else I can do. I know that my wave speed's provided here, but I can also calculate by taking my frequency times my wavelength. So I can get 50 meters per second. So there's a couple ways in which I can do this. So I can fill in all of these. My wave speed is constant, 50 meters per second. Now, with getting all these written in here, now I can start kind of plugging in numbers and calculating all of the frequencies and all of my wavelengths. So here goes. I'm going to jump because I already know that I have a wavelength here of 12.5 meters and I have a wave speed of 50 meters per second. So I can solve for my frequency is going to be the speed divided by the wavelength. And that's 50 divided by 12.5. And this frequency here is going to be 4 hertz. So knowing that this frequency is 4 hertz, I can now begin solving for my, I'm going to make the drawing, excuse me. Put this hump in here, put this in here, crests and troughs. That's one full wavelength from here to here. Now, my fundamental. Now remember, if I make this drawing here, that's only 1/2 of the total wavelength, right? It has another side over here that we don't have to grab. But think of it this way. It's going to be half the frequency of my second harmonic. So my fundamental is going to be 2 hertz. It's going to be half the frequency, so it's going to have twice the wavelength, 25 meters. Now, I can just pick whichever one I want to solve next. If I do my third harmonic, it's going to have 3 times the frequency as my fundamental. So 3 times 2 hertz, it's going to be 6 hertz. And therefore, it's got 3 times the frequency. It's going to have 1/3 the wavelength. So 1/3 of 25 is 8.3, right, repeating meters. And last but never least, for my fourth harmonic, I know that my second harmonic has a frequency of 4 hertz. The fourth harmonic is going to have twice the frequency of my second harmonic, so it's going to have 8 hertz of frequency, and it's going to have 1/2 the wavelength, or 6.25 meter. 8 times 6.25 gives me 50 meters per second. And there is the short version of solving for standing waves that we'll be doing in class.